was talking. Hello and good day, pre-algebra. We're covering CO44, which, as I was saying, is kind of a nice summary of everything that we've done so far. And the key term today is direct proportions. And a direct proportion is as one value increases, so does another. Okay? As one value increases, so does another. And then on the flip side of that, as one value decreases, so does another. I'll give you an example of this when you're done jotting that definition down. As one value increases, so does another. As one value decreases, so does another. Okay. Let's say that over spring break, your parents want you to paint a fence, right? What can you tell me the relationship is going to be? The longer you spend painting the fence, the more paint will be on the fence, right? The more time you spend, the more the project you'll complete. As one value goes up, time, the other value, paint on the fence, goes up as well, right? That's an example of a direct portion. Both values are either going to increase or decrease, okay? So this is what you can expect to see on your test here. A situation, and then 4 questions on it, A, B, C, D. And we can answer each of these questions by going back to something we've already done. Like I said, CO44, we've only been working with direct proportions so far, and so CO44 kind of summarizes everything. So a car travels 300 miles in 6 hours, okay? This is the given piece of information here. A car travels 300 miles in 6 hours. Letter A. How many miles can the car travel in 8 hours? How would you set this up? Are you going to set up a proportion and use cross products? Are you going to set up a proportion and do a unit rate? Are you going to set up a proportion and convert, from feet to miles or from inches, like what we did in CO43? Aiden.
300 divided by 6, and that's 50, so you could add another 2 50s, because 6 plus 2 is 8. So adding 2 50s would correlate with adding 2.
Okay, so one method here is to use unit rate. And Aiden, when you said divide 300 by 6, right? If our original rate is the car travels 300 miles in 6 hours, I should put labels on here, 300 miles in 6 hours. Aiden's saying, well, if I divide 300 by 6, that gives me 50 miles in 1 hour, right? The definition of what unit rate is, how much in one of something, okay? And then Aiden's saying, well, okay, if I'm going 2 more hours, right, from 6 hours to 8 hours, that's plus 2 hours. That means I'm adding 2 50s onto my 300 here. Because for every hour that we travel, we're going 50 miles. If I go 2 extra hours, I'm going 50 miles further twice. And that's how he got his answer of 400. Right? Cool. Anybody have another method that we could use here rather than unit rate? Kind of going back to PO42 a little bit here. This is method number 2 here. 300 miles in 6 hours is equal to how many miles in 8 hours? Right? Set up a proportion that we can use cross products to solve here. 300 miles in 6 hours equals how many miles in 8 hours? Using cross products to solve this, right? 300 times 8 is 2,400. And that equals 6m, 6 hours times our variable, what we're solving for. And dividing 2,400 by 6 gives us the same 400 miles that we got using unit rate. Okay? Now we're using this information to now go to letter B and say, how many feet does the car travel in 8 hours? We now know that it can travel 400 miles in 8 hours. That's what we answered in letter A. I'm now asking you, how many feet does the car travel in 8 hours? So what are we using here? Proportion, unit rate, or unit conversion? Kind of the three main things we've talked about so far this unit. Aiden? Unit conversion. We know how many miles. We want to know how many feet. Okay? So we're going to be converting 400 miles to feet. How are we going to start that? What do we know about miles and feet? Anna?
3 feet is 1 yard.
Okay, there's 3 feet in a yard.
You could set it up to equal a yard and then in yards can go into a mile.
Sure. We've got conversions for feet in yards and yards in miles. We could do it that way. But Anna, do we also have a conversion that gets us from feet directly to miles?
Oh, yeah.
Which is what?
5,280.
Okay. So for letter B here, we know that there are 5,280 feet in 1 mile. Right? And what do we want to know? How many feet there are in 400 miles. Because if the car travels 400 miles in 8 hours, and we want to know how many feet the car travels in 8 hours, we essentially want to know how many feet are there in 400 miles. So we have a scale factor here, right? Just like the stuff that we did back in CO43. Multiply by 400 to get from 1 mile to 400 miles. Multiply by 400 to get the number of feet. Okay, so 5,280 times 400 gets us, oh boy, that's a lot, 2,112,000 feet in 400 miles. Okay. Again, not new concept. We covered this in CO43. It's now recognizing that, okay, for this question, I need to convert units, so I need to set up a scale factor type situation, right? Like we've done before. So how many feet does the car travel in 8 hours? 2,112,000 feet. Questions so far? Okay. Letter C. How many miles is the car traveling per hour? How many miles is the car traveling per hour? Carly. And we kind of already answered that one, right? Using Aiden's method for the first one, unit rate. How do you know that we're using unit rate here? What's your key for that we're be using unit rate in this question? Carly, how'd you know? Right, per one of something, right? Per 1 hour. Whenever you've got that, you know that you're dealing with unit rate. So like we did in letter A, we're going to take our 300 miles in 6 hours, or we could take what we found as the answer for letter A, 400 miles in 8 hours. Either one's going to work because they're proportional. And we're going to divide 300 by 6 to get 50 miles per 1 hour.
What did we divide from there?
300 divided by 6, right? To get a unit rate here, we divide the numerator by the denominator, because our goal is to get from 6 hours down to 1 hour. How we do that is we divide by 6. 6 divided by 6 is 1. So kind of like scale factor up here as well, 300 divided by 6 will be 50. Okay, just scale factor with division instead of multiplying. So 50 miles per hour for letter C, unit rate. And finally, letter D, how many feet is the car traveling per second? Is this going to be a proportion, unit rate, unit conversion? Aiden?
Unit conversion and then unit rate.
Yeah, it's kind of a combination of unit rate and unit conversion, because it is per second, per 1 second, which is what unit rate is, per one of something. But we also have to go from feet or miles per hour, right, to feet per second. Okay, so it's going to be a unit conversion thing as well. So let's start with letter C there, 50 miles per hour. Okay, we want to get down to seconds. How do we move from hours to seconds? You think back to CO43, when we climbed up units, when we went from seconds to minutes to hours, we multiplied in our scale factor. So now we're kind of climbing down the ladder, right? We're going from hours to minutes to seconds. So what are we going to need to do here, Maggie? We're going to need to divide. And since we're climbing down, our first step here is actually going to be a unit conversion. Normally we start out with a scale factor, but when we're going smaller, when we're going backwards, we need to start out with a unit conversion. We're saying that 1 hour is equal to 60 minutes, right? We can't really divide 1 by anything to be productive here, okay? So we're saying that if you can go 50 miles in 1 hour, that's the same as going 50 miles in 60 minutes. Unit conversion first. Now what are we doing next? If we just did a unit conversion, that means the scale factor is coming. And he always told me that we're going to need to divide here. What are we going to be dividing by, Aiden?
Divide 60 by 60 seconds.
We're going to divide 60 by 60. Because what that does, dividing 60 minutes by 60 gets us down to 1 minute. Right? Now, there's actually probably something that we should have done first here, honestly. Since we want our numerator to be in feet, we probably should have converted 50 miles to feet first. So multiplying 50 miles by 5,280, I'm just going to add that in here. Okay, 50 miles times 5,280, because there are 5,280 feet per mile. That gives us 264,000. Okay, so we're traveling 264,000 feet in 60 minutes. We're dividing 60 minutes by 60 to get down to 1 minute, which means we'll be dividing 264,000 by 60 to figure out how many feet we're going per minute. And that is 4,400. So scale factor means we're dividing both numerator and denominator by the same thing. Since we just did a scale factor, what comes next? Unit conversion. What are we converting to? Minutes to seconds. 4,400 feet in 1 minute equals 4,400 feet in 60 seconds. Right? We're dropping down a unit now. We're getting close, right? Because we've got our units in feet and seconds, which is what we want. How many feet is a car traveling per second? We got one step left. What do we got to do here? Annika? Divide by 60 again. It's scale factor time. And we're dividing by 60 to get our denominator to be 1 second. Here's that unit rate here, right? So 4,400 divided by 60 is 73 1/3. And my phone's ringing, so okay, so we've got 73 1/3, or 73.33 feet per second. Think about that. I mean, this is not just a made-up situation here. I mean, how often are you driving a car at 50 miles per hour? Like, it's not that fast, right? It's like highway speed, not freeway speed, but highway, okay? Every second at 50 miles per hour, you're traveling 73 feet. That's about, I'm about 6 feet tall. That's about 12 of me every second at 50 miles per hour. What's the speed limit on 35W or I-94? Anyone know? 70 miles per hour. I mean, even 20 miles per hour faster. And the speed limit's 70, which means your parents are actually driving what? 75 or 80, right? I mean, you're cruising 73 feet. That's a fairly long distance that you're traveling every second at 50 miles per hour. It's kind of one of those things you think about, like, huh, that's kind of fast. Okay? So this is the process that you're going to be doing for the rest of these situations in CO44. It's nothing new. It's going back to things we've already done. Unit conversion, unit rate, setting up proportions. It's just knowing what to do and how to set it up. So I'm going to have you start to work on the next one. We'll go over answers before classes finish, but I want to see you do the work here and know how to set these up. So we'll pause the video and we'll pick it up shortly. In here, I'll turn my mic on so it actually records. We're back to talk about this question here. And like I kind of said, you're basically looking at 3 different options here. And sometimes you can use more than one method to get the answer. But is it going to be a proportion? Is it going to be unit rate? Or is it going to be a unit conversion? So a 40-ounce jug of grape juice costs $4.80. Okay. Letter A, at this rate, how much would 65 ounces of juice cost? This is a really great opportunity to set up a proportion, okay? Because you know the relationship between the first jug, 40 ounces for $4.80, 40 ounces for $4.80, and you want to know how much a different jug of juice will cost that is 65 ounces. And you know the rates are equivalent because it does say at this rate. So you know 3 of the 4 pieces. You know the size and the cost of the first jug, and you know the size of the second one, which means you're solving for one thing, the cost. Great proportion here. 40 ounces for $4.80 equals 65 ounces for how much? Right? And what method would you use to solve this? Solve a proportion. Cross products. Okay? 40 times C, and we can drop off the units now because we're setting up an equation here. But 40C is equal to 65 times 480. So 65 times 480 is 312. So 40C equals 312. Loving those work out evenly. It's nice. Divide both sides by 40. And our cost, we get 7.8, which in terms of money is how much? Not 8 cents. $7.80, right? That 8 is in the tenths place, okay? So, letter A, how much for that 65 ouncer? $7.80. Who was successful? Okay, if you were not successful, anybody have any questions now after you're going over it? It's almost like once you see it, it's like, oh, yeah, of course, that makes sense, right? But it's doing it on your own and trusting yourself, right, that you're setting it up correctly. All right, let's look at B. You find a different brand of grape juice that is a 35-ounce jug for $3.85. Which jug of juice is the better price per ounce? What are we using here? Better price per ounce. There's a phrase here that really stands out to me. Anything in this stand out to anybody else? Annika? Per ounce, right? Per one of something, which means let's go with what? Unit rate, okay? And since we're comparing two different jugs here, we've got this 35-ounce jug for $3.85, okay? And our 40-ounce jug for $4.80. We're looking at the cost per ounce for each of them. Which one's the better price? Which one's the better deal, right? The $4.80 costs more, but you also get more juice. So that makes sense, okay? We're looking for the better price per ounce. So letter B here, let's find the unit rate. Price per ounce, $4.80 for 40 ounces. How are we going to get the unit rate here? The price per ounce. What will we be doing? Turn the 40 into a 1. So that's what we want, the price per ounce. And since we're dividing 40 by 40, we're also dividing our numerator by 40. So 480 divided by 40 is 0.12. So this juice, our original one, is 12 cents per ounce. Now we go to our other one. This one is $3.85 for 35 ounces. We again want to get this to be the price per ounce. So we'll be dividing by 35. Dividing by 35. And $3.85 divided by 35 is 0.11, which in context means what? John? Sorry? Oh yeah, $0.11. So our original jug is 12 cents per ounce. This one is 11 cents per ounce. Which one's the better deal? The second one, right? This one here, okay? The 35 ounces for $3.85 is the better deal because it's 11 cents per ounce versus 12 cents per ounce. Big difference? No, but it's the better deal, okay? Questions on letter C? Sorry, questions on letter B. We'll do C now. Okay, letter C. You've got $20 to spend and decide to purchase as many jugs as you can of the juice that is cheaper per ounce, which we now know is this 35 ounces for $3.85. How many jugs can you buy with 20 bucks? And how much money will you have left over? This one isn't really a proportion question. It's just kind of like a, dealing with life question. If you've got a certain amount of money to spend and you know how much something costs, how much can you buy with that much? Okay. How are you going to work this out here? Use a calculator. What are you going to put in the calculator? I mean, calculators only get you so far. You got to do it. Yeah.
I forgot what I did.
Okay. What answer did you come up with? Okay, so May got 5 jugs of juice as an answer. Did anyone else get that and want to explain how? Yeah, Anna? Oh.
I don't know.
Okay. Anyone want to explain? Yeah, go ahead.
Okay, I think I did something times 5. I can't remember.
Probably 385?
Yeah.
Okay, so we know that, $3.85, we've got $20 to spend. We know that we can buy more than like 2 jugs, right? Because 385 times 2 clearly isn't all the way up to 20. We know that we can't buy 10 jugs because 385, if we round it up to 4, times 10, that's 40. So 5 seems to be a good way to estimate this. So Maggie went ahead and she multiplied $3.85 by 5 just to see where she got. And 385 times 5 is $19.25. Okay, since we've got $20, that means we can buy 5 of them with 75 cents left over, right? Because 20 minus 19.25 is 75 cents change. Anybody have a different method? This is kind of a logical guessing and checking, which is fine, right? We knew it couldn't be something like 2. We knew it couldn't be something like 10. So let's kind of work our way down. Anyone have another method that they use here? Well, if we know the whole, which is $20, and we know the part, which is $3.85, right? The cost. Dividing 20 by 385 will tell us how many jugs we can buy. And we get 5.19 as an answer for this. Okay? Which means that we can buy 5 whole jugs of juice with a little bit left over. Right? So then, once you realize that you can buy 5 of them, now you'd figure out exactly how much 5 jugs cost by multiplying that by 385. You get the 1925, and we still get the 75 cents change there. Okay, but it's I'm sure you had a question similar to this back in 4th grade, 5th grade, 3rd grade when you were doing addition and subtraction with decimals and you brought in money. Okay, so again, this CO44 is all stuff that we've done before, all stuff that we've worked on before. All right, we are going to save the other 2 for tomorrow. The only homework tonight is to finish up Khan Academy. If you did not turn in your math packet, make sure I get that ASP as soon as possible, ASAP as well. With gusto, that's how you math.